The next moon that we're going to look at is Europa. So Europa is the second moon away, orbiting from the center of Jupiter. So Jupiter is very recognizable because it has a nice smooth surface with a lot of cracks in it. And what we're going to find is that Europa is almost like almost the exact opposite of Io. So all the volcanic activity that occurs here with rocks, we're going to see that here on Europa is replaced with ice. So looking at Europa, what you see is that if you zoom into the surface here, there's very few craters, but you see that there's extensive cracks or like these crack marks are all over its surface. So, and if you zoom into these pictures here, these look like frost. So this looks like ice on the surface of Europa. So because you don't see any craters, that must mean that the surface of Europa is active to cover up those craters, and what's moving around is not rocks anymore, but ice packs moving around on the surface of Europa. So just like with Io, Jupiter's tidal forces exerts more force on this side. Here we're looking at Io again, so exerts more force on Io on this side and exerts less force on Io on that side, and that causes Io to warp and stretch, and that generates heat that's able to melt the rocks to make Io volcanically active. Europa is similar. So here though, the role of rocks is replaced by ice. So the interior of Europa is ice, and all that warping and heating melts the ice, so that you find that beneath the surface of Europa, instead of lava, what you have is an ocean of water. So there's liquid water beneath the surface of Europa. So Jupiter's tidal forces warp and stretch the interior, and so in Europa, the role of rocks and magma or lava is replaced by ice and water. So Europa then, just like the Earth has, you can say, a lava ocean beneath its surface, or an ocean of melted rocks, Europa has an ocean of liquid water beneath its surface. So you can see the effect again here. As Europa orbits Jupiter, it gets warped and stretched, and that warping and stretching changes its shape to the point where all that friction generates heat. And that heat, in this case, it melts the solid parts, but the solid parts are ice. And the melted ice becomes water. And just like Io has volcanoes of melted rock or lava, Europa has volcanoes, but in this case here, of ice lava. So you can see the picture again here now. So the warping and stretching of Jupiter, the tidal forces of Jupiter onto Europa, exerts more force on this side, less force on that side, and that warping and stretching generates heat, and that heat melts the ice and turns it into water. And so here you can actually see geysers being emitted, flowing out from the surface of Europa. So you see Jupiter in the background, and the tidal forces of Jupiter onto Europa, more force on this side, less force on that side, warps and stretches it until you have geysers. The water melts and gushes out onto the surface as geysers. So What we find then is actually, estimating, Europa actually has more water than Earth does. And because of that, it's possible that, and this is liquid water, so wherever you have liquid water, it's possible that there's life there. So another feature that stands out for Europa is it may be possible that there's life beneath in the liquid ocean. And that term there, so life outside of the Earth, is called exobiology. So also, Europa has a weak magnetic field. So let's look at its internal structure. It also has an iron core, but here it has an icy crust, and beneath the icy crust, the ice gets melted, so you have an ocean beneath it, and there's water beneath in this region here. So again, a very recognizable structure. You see very few craters, so that it must be tectonically active. But in this case here, the role of continents moving around, rocky continents moving around, is replaced by the role of ice moving around.